motion are three physical laws that describe the relationship between the motion of an object and the forces acting upon the object. I'm going to be explaining how seatbelts save lives and how Newton's laws are directly related. I'm going to be explaining how seatbelt saves lives and how Newton's laws of motion are directly related. Because the seatbelt force stopped me from accelerating forward. I stopped due to inertia. Inertia is the body's tendency to resist a change in motion. My friend over here is not so lucky because there was no force to stop him from accelerating forward, and the inertia moved him into the windshield and onto the floor. A body at rest will stay at rest, and a body in motion remains in motion unless an external force. Newton's first law of motion states a body at rest, which is me, for being protected by the seatbelt from stopping me from moving forward, and him hitting the windshield and staying in motion. I'm going to be explaining the difference between balanced and unbalanced forces. Balanced forces, you can't see the gravity exerting a force down. The golf cart is exerting a force down onto the driveway. The balanced force is the golf cart at rest plus the gravity. The two forces are equal, so the net force is zero. Net force is the sum of all factors acting on the object. Safety first. An example of an unbalanced force is a force applied in one direction is greater than the force applied in the opposite direction. Unbalanced forces acting on an object change in speed and direction. Newton's second law of motion. The force of an object is the mass times its acceleration, or the formula that we use, F equals n times a. If the force is up, the acceleration is up. If the force is increasing, the acceleration is increasing. The force needed to accelerate is directly proportional to the mass. The larger the mass, the force is needed to accelerate. Me being a larger mass, it took more force for me to accelerate, and my friend, him having a smaller mass, it took him less force to accelerate, but when I was going, I was accelerating faster while he was staying at constant speed. Newton's third law of motion says, every action there is an equal and opposite reaction. The movement reaction force helps stay securely in place and not move forward. The seatbelt is restraining my body from accelerating. This proves Newton's third law of motion. With every action, there's an opposite equal reaction. Now let's go talk to an expert in the field.
Hi, I'm here with Dr. Jamie Williams, who's a biomedical engineer and biomechanics expert. She is an expert on traumatic brain injuries and musculoskeletal biomechanics and injuries such as car crashes. Okay, Dr. Williams, my first question is, how does Newton's law of motion help us understand the importance of seatbelt safety in the different types of vehicles such as cars and airplanes?
So Newton's laws of physics apply to car crashes. In fact, all three of Newton's laws of physics apply to car crashes and how people behave during those car crashes. So Newton's first law of physics is that a body at rest remains at rest and a body in motion remains in motion until acted on by an outside force. So when a car is driving down the road and it hits a wall, it comes to rest because of an outside force because it hit the wall. Well, the people inside the car want to continue to be in motion like they were before the car crashed. And so when the car crashes, the car comes to a stop, the people inside the car are going to continue moving just like they were before the crash until they experience an outside force. And if you're not wearing your seatbelt, that's going to come from the steering wheel or the dashboard or the windshield or the seat in front of you. And that's when the injuries occur. So to understand the injuries, then we get to Newton's second law, that force is equal to mass times acceleration. And so the force that the body is going to see in a car crash is going to be equal to the mass of the body and the rate of the acceleration. Or in a car crash, we're going to talk about deceleration because we're slowing down. And then Newton's third law, that for every action there's a equal and opposite reaction. So when the body moves forward and hits the steering wheel or hits the windshield, those objects or surfaces of the car are going to apply a force back to the person, and that's why we get injuries. So the seat belts are there to provide the external force to slow us down before we hit something inside the car. And by doing that, it's going to reduce the amount of the force that we experience and therefore make it less likely that we sustain injuries.
Thank you so much. Okay, for my second question, are there any specific guidelines or recommendations for using a 5-point car seat with babies or children based on Newton's laws of motion?
So we do use car seats. Car seats have specific harnesses, especially for little babies. So it's a 4-point attachment, but the reason that design is used is because it applies force over 5 different points on the baby. So an adult seatbelt is what we consider a 3-point seatbelt. So it goes from one shoulder across the body to the opposite hip, and then across the pelvis to the other hip. And the reason that the seatbelts do that is because the shoulder and the hip bones are really big and really hard. And so we can absorb the forces from the crash that's exerted through the seatbelt onto our bodies through those bones. But babies' bones are not as big, and because they are growing so much, they're not as hard, they're not as calcified. And so in order for a baby's body to be able to withstand those same crash forces, we want to spread those forces over more parts of their body. And so that 4-point harness actually crosses the baby's body in 5 different points. It's both shoulders, where the shoulder straps come over, and then it connects through a clip that's right at the sternum, which is that big, strong bone that's right in the center of your chest that helps to protect your heart. And then from there, it goes down towards the legs and applies forces over both of the hips. So for a baby, we use both shoulders, both hips, and the sternum so that we can protect a baby's fragile body from the forces that are generated during a crash.
Thank you so much. Okay, Dr. Williams, based on Newton's laws of motion, what do you feel it is important for people to know when it comes to seatbelt safety?
So people know that in car crashes, the cars are damaged. And that's because that's how the forces are distributed onto a car due to the impact that it has. And knowing that the bodies inside those cars, Newton's first law, those bodies are in motion and they want to remain in motion until acted on by an outside force. So if you don't have your seatbelt on, you're going to see the same crash forces that damaged that car. And so you can imagine that if it was enough force to damage the cars, it's going to be enough force to cause a lot of damage to your body. And so wearing a seatbelt allows you to be slowed down or decelerated over a longer period of time. And because force is equal to ma, if we make the deceleration a bigger number, a smaller number, then we can make the forces a smaller number, and we can reduce the forces that the body sees. And so it's important for people to know that if you choose not to wear your seatbelt, you're going to see the same crash forces that car did, and you're not going to fare as well as the car does, and the cars get a lot of damage. So you can imagine what a body inside that car would end up looking like.
Okay, thank you so much.